So, by the end of this video, you will be able to identify the basic properties of projectiles and their motion, explain and detail the formulas for projectile motion, answer multiple choice questions about projectile motion, and answer short answer questions about projectile motion as well. So let's get started by looking at what projectiles actually are. So, what is a projectile? A projectile is essentially an object that is launched into the air with some initial velocity and at some initial angle. So these velocities and angles don't have to be specified. They could vary, right? So it could be at 90 degrees, it could be at 0 degrees, it could be at 45 degrees to the horizontal, etc. And the initial velocity can also range to whatever the question will give you. So there are a couple properties about these projectiles that we also need to take into account and also mention whenever we are asked to define what a projectile is. And these properties will help us identify what objects are projectiles and what objects aren't. So potential multiple choice questions that you can get regarding projectile motion is either they'll get you to make some very simple calculations about the motion of a projectile, but most often than not, it'll be mostly about identifying what substances are projectiles and what substances aren't. So it'll get you to test these two properties I will look at first of all. So the first thing is that projectiles aren't acted on by any additional forces during its flight except gravity. And that is just a general thing that we look at. And the two assumptions that we make when we think about projectiles is that, first of all, the vertical acceleration due to gravity is constant, and the effects of air resistance are negligible. So these have a few results on what we actually end up doing. So when we have a projectile, we assume that its horizontal velocity can be constant and its vertical velocity is what changes. So let's take a look at why. So we are launching a projectile with some initial velocity at some initial angle, right? Depending on what that is, that projectile will either have a vertical component, a horizontal component, or most of the time it'll have both a vertical and horizontal component if it's flying at an angle that isn't 90 degrees or 0 degrees. So because it has a vertical and horizontal component, that means that there are forces that can act on either one of them. In real life, the air resistance will act on both horizontal and vertical components. However, we neglect air resistance. So our second assumption is that the effects of air resistance are negligible. So we neglect air resistance when we talk about projectile motion, and therefore we can make the assumption that the horizontal component of velocity for a projectile will always be constant. No matter what the number is, it will always be constant. So even if the horizontal velocity is 0, that will still be constant throughout its entire motion. Its vertical motion, however, and its vertical velocity, will change, however, because it will experience a constant acceleration of 9.8 meters per second down towards the ground, or negative 9.8 meters per second, depending on how you would justify up as the positive direction, for example. So even if we start off by shooting a projectile only to the horizontal, so at 0 degrees, that means we start off with 0 vertical velocity. After we let go of that projectile, the only force that's going to act on it is gravity, and gravity is going to act downwards. So even though we start with 0 vertical velocity, that vertical velocity is going to start increasing in the downwards direction or decreasing in the upwards direction, right? Because it's going to be experiencing a force due to gravity, and therefore causing it to accelerate. So those are the two assumptions we made, and this is a general definition of a projectile. Let's move on to what general calculations and laying out calculations will look like. So this is what a general calculation will look like whenever we approach projectile motion questions. So this red arrow will indicate essentially the direction that projectile is being shot out at. So U will indicate the total velocity of that projectile. And we know that the velocity of this projectile and the motion of this projectile can be split into two components via a right angle triangle. So we have the angle theta, which is what the angle it's been shot at with respect to the horizontal. And so we have the horizontal component, which is UX, denoted as the x-axis, so horizontal component. And we also have UY, which is denoted as the y-axis, or the vertical component UY. So in this case, this projectile has both horizontal velocity and vertical velocity. From what we just learned, we can assume that this vertical velocity is going to decrease at a steady rate, or it's going to decrease at an increasing rate because its acceleration is constant, right? So it's going to start decreasing. Why is it decreasing? Because gravity is acting on it in the opposite direction. It's going to act downwards, right? So vertical velocity is going to decrease until vertical velocity reaches 0, and then afterwards it's going to start increasing in the downwards direction. So can we develop formulas now to think about the vertical and horizontal component? How can we convert this velocity u via a formula into ux and uy? So the way we do that is we use the theta value to use trigonometry. So we can say that cos 30, which is going to be adjacent of a hypotenuse, cos 30 is going to equal adjacent, which is ux, divided by the hypotenuse, which is u. So cos 30 is going to equal ux divided by 30. So let's assume u over here is equal to 30, right? If u here was equal to 30, then cos 30 will be equal to ux. So we're making a few assumptions here. First of all, let's assume that the angle theta is going to be 30 degrees and u here is going to be 30 as well. So then cos 30 is going to equal ux over 30. And so ux will be equal to 30 cos 30, which will be approximately 26 meters per second. So the general formula will be that cos theta will equal ux divided by u. So ux will equal u cos theta. The same principle can now be applied for the vertical component, where sine 30 will be equal to opposite over hypotenuse. So sine 30 will be equal to uy divided by u. Right, so uy is going to equal u sine theta, or in other words, if we continue with the same principle where the angle is 30 degrees and u is equal to 30, then sine 30 is going to equal uy divided by 30, which will equal 30 sine theta, which will be 15 meters per second. All right, now let's take a look at a few graphs depicting the motion of projectiles over time. So this is a comparison between the horizontal and vertical motions between a projectile motion. So we can see over here that the velocity of the horizontal component is going to stay constant over time. That's because air resistance, which will generally be the only force acting on it, right? Because as we throw a projectile, we are essentially making the assumption that we're not applying any forces on it except for gravity, and gravity doesn't work in the horizontal direction. So the velocity of this projectile in the horizontal direction will be at a constant value, as we're neglecting air resistance, which will be the only thing that will act on it. So it'll just be a straight line, a horizontal straight line that we'll draw as time is increasing. Acceleration, now if we look at it, it might not seem as much, but it'll also be a straight line where acceleration will be 0, right? So it'll be a straight line at the value 0. Vertical velocity now, taking a look at vertical velocity will change. So vertical velocity will change, and it will change at a constant rate because acceleration will be constant. So if we start off at this particular value in the positive end, that means that, or let's define positive as upwards, right? So that means that the projectile is being thrown upwards. Then it's going to start decreasing at a constant rate. Why? Because the vertical velocity will experience a force due to gravity, and that force will be constant, so that acceleration will be constant, so that we can say the rate of change of velocity will also be constant. That's why we see again a linear relationship, in this case a linear decrease. So velocity is decreasing at a constant rate until we reach this point, which is the 0 point. As it's reached the 0 point, the vertical velocity will reach 0, and then immediately the projectile will start to fall downwards, as the velocity will now be in the negative direction. So it'll be falling downwards now at an increasing rate. So over here we can see acceleration now. Acceleration is, again, because we see the horizontal straight line, we can say that acceleration is going to be a constant value, which in this case will be 9.8. And because it's below the axis on the 0 line, we can say it's going to be a negative value. So acceleration is going to be negative 9.8, and that will be because we've defined up as the positive direction. All right, let's go through a few formulas now that we use for projectile motion. They're essentially applications of the Suvat equations that we'll have looked at in year 11, but now we're applying them to each specific component of velocity that projectiles experience. So Vy, which is velocity in the y direction, we can equal that to Uy, which is the initial velocity in the y direction, plus acceleration in the y direction, times time of flight, or times time taken, or time passed during its motion. So if we want to find the final velocity of an object, or final velocity, we'll just have the initial velocity over here multiplied by the acceleration over time, and multiply that by time. So taking a look at this general motion, we can observe a few things about these projectiles. So as it is flying upwards, we can observe that it's going to reach this point of maximum height over here. What is special about this point is that at this particular point, our velocity in the vertical direction will be 0. So our velocity will be constantly increasing, but it will be increasing, the motion, like the position of our projectile, which is the ball over here, will be constantly increasing, but it will be increasing at a decreasing rate. Why? Because the velocity upwards is going to be decreasing at a constant rate, right? Due to acceleration over time, due to the 9.8. So our velocity upwards is going to decrease at a constant rate. And when that velocity is going to equal 0, the ball is going to stop. The only point where that ball reaches a 0 velocity is going to be at the very height of its projectile motion or its parabolic motion. After that velocity reaches 0, it's now going to reach into the negative values, right? And when it reaches into the negative values, the thing that is changing is the direction. So when it's in its negative values, it's going to be going downwards. And therefore, just before it hits its negative values, when v is at 0, we can say that it's at the highest point of its parabolic motion. So if a question ever asks you to detail the highest point of its parabolic motion, you'll let vy equal 0 and then solve for t to find the time when that occurs. All right, let's go through another formula now. So next formula is going to be this particular formula over here, which is Sy, displacement in the vertical direction, is going to be equal to uyt, which is initial velocity in the vertical direction times time of flight, times t, plus half ayt squared, which is going to be half acceleration in the y direction times t squared. So uyt is going to be the base distance traveled, and ayt squared is going to be the additional distance traveled due to acceleration, right? So if we say, for example, want to find the displacement or the highest point, right? How far away from the starting point are we when this ball reaches the highest point? Well, what we can do is we can go back to our previous equation, right? We can let vy equal to 0, and we'll know what uy is, we'll know what ay is, because ay will just be negative 9.8, right? So what we'll do is we'll solve for t in that particular equation, and we'll use that value that we get for t to plug it into this equation. And so because we know what the starting velocity is, because we know what ay is, as it's always constant, after we plug in t, we can get a value for sy, and that value for sy will be the highest point that it will reach to in comparison to its starting point, because sy will be displacement. All right, so a quick collation of the formulas that we looked at will be look something like this. So this will all be in the horizontal direction, right? So vx is equal to ux plus axt. Obviously, we can just say that vx is equal to ux because ax is going to be equal to 0. So at is going to be equal to 0 as well. Again, so this is the simplification there. Over here, we have the similar formula, s is equal to ut plus half at squared, all in the horizontal direction. Again, this secondary thing, half at squared, is going to equal to 0 because a is going to equal to 0. We have the next formula here, v squared is equal to u squared minus 2as. Again, the 2as will cancel out because the a will be equal to 0, so v squared is just equal to u squared. So the three formulas that we really have is v is equal to u and s is equal to ut. So v squared is equal to u squared is just another application of v is equal to u. So in reality, we only have two formulas, which is v is equal to u and s is equal to ut. Okay, the final bit of content that we'll look at before we go into the multiple choice is going to be practical applications. So what are practical applications of projectile motion? Well, when we talk about practical applications in physics, when you go into physics in class, you will be asked to most likely write some prac reports about investigating the properties of projectile motion, because physics as a subject is very experiment based. So they want a lot of experimental evidence, and it's getting students to experiment themselves so that they can demonstrate the properties that they learn. So a couple of practical applications of projectile motion could be rolling a projectile off of a bench and then trying to guess its landing location based on the values that you roll it off with. So you would know its starting velocity, you'd know its final velocity via calculations, and you can adjust those values or plug in those values and manipulate the equations to find its landing location. And potentially you could leave like a red cup or like a landing zone on your predicted area where the ball will land to check if that's where it lands. And a potential issue might be that air resistance could affect certain values, but as we're minimizing the scale of our application to a very small amount, it shouldn't be too disturbing. The next thing that we'll look at is investigating how the angle of launch affects things like range, time of flight, and maximum height. So this particular example is looking at how one factor will affect the different other factors that we look at when we're considering about projectile motion. And one of the other things that we look at is using a slow motion camera to observe the flight paths of various projectiles to validate the independence of horizontal and vertical velocity, right? And another thing, the final thing that we'll look at is simulations of all sorts of projectile motion scenarios. So with this, we'll reach the end of the content section of this video. Let's now move on to the questions. So let's first take a look at the multiple choice questions. What is the key assumption we make in projectile motion? Option A states they will experience horizontal acceleration. Option B states the gravity is the only force acting on projectiles. Option C states they will follow a linear path. And option D states gravity is not the only force acting on projectiles. So this is very relevant to the HSC definition of what a projectile motion is. So what a projectile is, sorry. So the answer to this question will be option B, which states that gravity is the only force acting on projectiles. So option A is wrong because the fact that they will experience horizontal acceleration, yes, while it could be true in real life where air resistance could provide a negative acceleration to that horizontal velocity, in projectile motion for physics, we discard the effects of air resistance. Option C is incorrect because even in real life, all projectile motion will follow a parabolic path. Option D, gravity is not the only force acting on projectiles. Yes, it could be true where air resistance is another force acting on projectiles, but again, we discard the effects of air resistance, so option D is also not correct. All right, with that multiple choice question done, let's move on to the short answer questions. So the first short answer question asks us, question number 1, a student releases a tennis ball from rest from the top of a 20-meter tall building. How long will it take to reach the ground? All right, let's take a look at the answer. So we know that because it's released at rest from the top of a 20-meter tall building, right? So we essentially just drop the ball. Yeah, so essentially we just drop the ball from a 20-meter tall building. So we know that the initial vertical velocity is going to be 0. And we know that the final displacement is going to be -20 because we're starting at the top of the building and we're waiting till it reaches the ground. So if the starting point is the top of the building, then when it reaches the ground, the displacement is going to be -20. So we know that S is equal to UYT plus half AYT squared. Another important thing is whenever we are talking about direction, make sure that you've disclosed what direction is positive, which direction isn't, and make sure to stick to it for all the values that you think about. So we've denoted that positive is going to be up and negative is going to be down. And so therefore, that's why S is equal to -20. So now we can apply the equation. S is equal to UYT plus half AYT squared because they want us to find the time, right? How long will it take? So they want us to find time. This is the Suvat equation that we can apply then. So then we can say -20 is equal to -4.9t squared. Why? Because uy is going to equal to 0. So this little bit of the equation is going to equal to 0. So we can ignore that. AY is going to equal to -9.8. So -9.8 times a half is going to equal -4.9. So now we can rearrange this equation, divide everything by -4.9 to say that t squared is equal to 20 divided by 4.9. So t is going to equal the square root of 20 divided by 4.9. And that's going to equal approximately 2.02 seconds to three significant figures, sorry. So now that we've covered the first question, let's move on to the second short answer question. Second short answer question has two parts. First part says, an experiment is conducted to measure the acceleration due to gravity by analyzing the motion of a projectile. Describe a method by which this experiment could be conducted. All right. So the first option, or the first answer to this first part is, an object could be released from various heights and the time of flight measured with a stopwatch. A line of best fit of height versus time squared could then be used to find gravity. So we know that S is equal to UYT plus half AYT squared, right? And so we know UYT is going to equal to 0. So S is just going to equal to half AYT squared, right? So what we can then do is, because S is equal to half AYT squared, and that is the equation that we're going with, we can now plot the graph of S against T squared, S against time squared, right? And therefore, if we vary the amounts of heights that we're changing, so T squared will be our dependent variable and S will be our independent variable, right? So our gradient will end up being y squared over, our gradient will end up being 1 over, or it'll be 2 times gravity. our gradient will end up being 2 times gravity, right? Because we're varying displacement, and we're trying to see how that affects the time of flight, right? So we're basically inverting the relationship s is equal to half a y t squared. And what we can do is we can find the gradient of that line of best fit, divided by 2, and then we'll get our value for g. The next thing that we can do is identify a safety hazard present in your experiment and a relevant precaution that should be taken. Answer to this question will look as such. Dropping heavy objects poses the risk of foot injury. As a precaution, wear closed shoes in the lab. So 1 mark, not that detailed of an answer required. This would get you the full mark. Let's move on to the next short answer question. The next question asks, a sniper is shooting at a hanging target that is 250 meters away. The target is horizontally in line with the barrel of the gun. As soon as the sniper pulls the trigger, the target will drop and fall to the floor. Air resistance is negligible. Should the sniper aim just above, just below, or at the target? Give reasons for your answer. Okay, so this is relating to projectile motion again, because as soon as that bullet leaves the gun, it's considered a projectile. So all the properties of projectile motion we discussed would apply here. So the sniper should aim directly at the target. Aiming horizontally means the bullet and the target will both have an initial vertical velocity of 0. Both will accelerate downwards in unison since acceleration is the same for both. And the horizontal motion of the bullet is independent of its vertical motion, so the bullet will stay in line with the falling target, eventually striking it. So as long as the target will drop and the bullet will also shoot, because acceleration due to gravity is going to be the same for both of them, what's going to happen is an acceleration due to gravity is going to be equal to negative 9.8, right? And that because that's equal for both of them, they're both going to experience the same vertical, they're both going to experience the same vertical velocity. And therefore, as horizontal velocity is unchanged, as long as we're directly on the target, the bullet should hit. If the target was staying stationary, we should aim to most likely aim the barrel a little bit upwards and then shoot so that the bullet can experience a parabolic arc, which it will always do which it will do regardless. And so we're trying to now adjust that parabolic arc such that when it finishes, it'll finish on the target. So we'll aim the gun barrel a little bit upwards so that when the bullet undergoes its parabolic motion, it'll end up striking the target. But in this case, since the target is also falling downwards, we won't need to aim the barrel upwards. We'll just need to keep it locked on the target. Let's move on to our next short answer question. Our next short answer question states, an object is projected from level ground with a launch velocity of 30 meters per second and a launch angle of 60 degrees to the horizontal, and it asks us to calculate the time of flight. All right, so collating our data over here. So it's launched at 30 meters per second, so that big arrow will be 30 meters per second, and its launch angle will be 60 degrees, and we'll have a vertical and horizontal velocity. So uy is going to equal 30 sine 60, vy is going to equal 0 initially. And a launch angle of projected from the level ground. So Vy, which is the final velocity, is going to equal 0 because it will land it. So we're calculating the time of flight, which is essentially how long it stayed in the air for. And so time of flight, time will be ticking until that velocity equals 0, which is when essentially the projectile either reaches its maximum height or it collides with the ground. So Vy is equal to uy plus ayt. T is equal to Vy minus uy divided by ay, which is equal to negative 30 sine 60 divided by negative 9.8, which is approximately 2.65 seconds. And that will get you 2 marks there. Our final short answer question will be as such. A cricket ball is thrown from one player to another player 95 meters away. What is the slowest speed at which it can be thrown and still cover the distance? So trying to find the maximum distance that it can cover in the shortest amount, and what velocity will be the slowest velocity such that it will still make it. So the optimum angle is going to be 45 degrees. And this is just something that you guys should be knowing, right? Because if it's anything less than 45 degrees, due to its parabolic motion, it won't make it at the same speed. So we'll have to increase velocity for it to make it. If it's anything greater than 45 degrees, it'll have a very steep parabolic motion and therefore will require more speed to compensate for that as well. Therefore, we'll need to be throwing the ball at the optimum angle. So we know that the horizontal displacement is 95 meters, which is equal to uxt, right? Because the half at squared is going to be cancelled out. So we know that time is going to equal, the time of flight is going to equal 95 divided by ux. Sy now, we know that's going to equal 0, right? Because at the very end, it's going to just hit the ground or hit the cricket player again, and we're assuming the vertical displacement there is going to equal 0. So we know uy plus uyt plus half ayt squared is going to equal to 0. We can divide both sides by t, because if we factorize the t out, the sy is initially 0 at t is equal to 0. So we already know that. So we can just divide everything by t. And then we know that t is equal to 95 divided by ux. So we know uy is equal to, uy minus 4.9 times 95 divided by ux is equal to 0. So uy is equal to 465.5 divided by ux. So we know now that v sine 45 is equal to 465 minus 0.5 divided by v cos 45. So then we can say that v squared is equal to 931 by dividing both sides by sine 35. And so then we can say that v is equal to approximately 30.51 meters per second. All right, I hope you guys understood those questions and what type of questions that they'll be asking you regarding the projectile motion. Let's take a quick review of what we've covered so far. So what we've just covered includes projectile motion, formulas for vertical and horizontal motion, multiple choice questions and strategies, and short answer questions and sample answers. I hope you all enjoyed.